Ladies and gentlemen, welcome to our physics class. And in this physics class, we are just going to have our physics revision, of which we are going to look at 2023 physics exam paper. And basically, we are focusing on question 7, sorry. So there were 7 questions on section B, and for now I'll just look at the 7th question. So our revision will be short, and the question we are looking at is saying a worker pushes a 500 gram box with a horizontal force of 0.22 kilonewton across a level floor as shown in the figure below. Then we have been told that the coefficient of kinetic friction is 0.35. Calculate the dash A, the friction force, and then 2, acceleration of the box. Then B is saying the coefficient of static friction between the floor and the box is 0.04. Find the smallest angle from the horizontal at which the box begin to slide. Then C, which will be your assignment. I'm not going to do this one. This is more of theory. So C is saying list 2 properties of static friction. List 2 properties of static friction. So let's quickly go in details and look at the solution for this particular question. So if you look at this question is falling under Newton laws of motion. So go and check up the lecture class I taught on Newton laws of motion, and also you check up the revision class of Newton laws and motion, where I had to solve certain examples. Okay, so from here we can collect our data. So if you look at the data, we have been given the mass, which is equal to 55,000 grams. So you need to change it into kgs by dividing throughout by 1,000, and this will be 55 kg. Okay, then the other thing which we have been given, it is the force, the horizontal force, which is simply 0.22 kilonewtons. So we are going to multiply it by 1000 so that we can have it in kg. So when you multiply 0.22, when you multiply it by 1000, 0.22 times 1000 is simply giving us 220 newtons. So 220 newton. Then one thing we have been given is the coefficient of friction, K, which is simply equal to 0.35. Okay, so from there, another thing that you have to understand is the free body diagram of this particular object. So this object is something that is like this, and then if this is the center of mass of this box here, so the forces that are acting on this particular object is 1, the downward force, which is Fw, and which is just the weight. Then we have another force which is acting on it, the upward force, which is the Fn, which is the normal force. And then we are having another force which has been introduced, which is the force, the resultant force, which is simply F, and this force is equal to 220 newtons. From here we can simply also look at the other force, which is acting on this particular object, and this is simply the frictional force. So the frictional force is the one which is acting in the opposite direction of the resultant force. So let's quickly look at the solutions now. Let's quickly look at the solutions. So I'll start with the first one, which is I, the frictional force. So for me to have the frictional force, I have to use the formula, which is the coefficient of static friction is equal to the frictional force over the normal force. The frictional force over the normal force. I hope you can remember this from Newton laws of motion part 2 revision. We also talked about this same coefficient of friction when we discussed work, energy and power, and that is for revision 1. So if you make the subject the formula, so you make friction force is equal to mu k multiplied by Fn, okay, which is the normal force. So mu, which is the friction force, is equal to the coefficients of friction we have been given. It is 0.3, 0.35. So we have 0.35 there, and then we are going to multiply it by the normal force. Now the normal force in this case, it is something that you need to look for. So basically when you talk of the normal force, which is Fn, is simply equal to Fw. Fn is simply equal to Fw, and you know that Fn is simply equal to Fw is just mg, okay, mg. So Fn is simply equal to m is the mass, which is 55 kg, and gravity, the acceleration due to gravity, we can use 9.81. So Fn in this case, you're just going to say 55 times 9.81, which is giving us 539.55 Newton. So this information we have there is the information we are going to use to get the final answer. So the frictional force, okay, is simply equal to 0.35 times the normal force, which is simply 539.55, like that. So when you multiply that guy there by 0.35, you're just simply getting 189 Newton. 189 Newton. So this was the answer for the friction force, and this was equivalent to 4 marks. One thing I would love to explain is this 4 marks is not just about solving, but it's also for the free body diagram. So make sure that you are able to illustrate the free body diagram. It's very, very important. Okay, I don't know if there is any questions from you guys. If there is any question, please feel free to ask the questions. Okay, since we don't have a question, we'll move on and look at, okay, I've seen a hand. Please feel free to ask.
The frictional force, aren't you supposed to express it as a negative?
The what?
The frictional force.
Okay, yeah, we can express it as a negative since it's going in the negative direction. That's very okay. Thank you for that clarification.
Okay, thank you. Thank you.
Okay, so let's move on and look at the second part. So guys, like I always state, we give you the information which you are going to expect in the final exams. So just make sure that you go through the lecture videos we do post, the revision classes we put there, and also these same classes. So look at this one again. Find the acceleration of the box. So according to the information we have this as our box here, and this box is having this force here, which is equivalent to 220 Newton. So 220 Newton. Then you have the friction force, which is simply equal to F, which is simply equal to 189 according to the data we have. So from here, what you have to do is, since the acceleration is in the horizontal, so these are the forces of interest. You know, the Fn and Fw are just having the same amount, so there is no acceleration in the y-axis. So you're going to say summation of forces in the x-axis, since it's a vector, is just simply equal to the what? It's just simply equal to F, the net force. Okay, the net force, which I can say the net force, F net. Then we know that force is equal to mass times acceleration, since there was that acceleration. So from there, what you can simply say, you can say this this mass times acceleration should be equal to the summation of forces in the x-axis. So we're going to say MA is equal to summation of forces in the x-axis. So according to the summation of forces in the x-axis, so MA will simply be equal to the force there minus the friction force, or we can say plus negative 189, okay, which is just the frictional force. Let me just write that and write it in that particular way. So that and FF, okay, of which we know MA is simply equal to the force we have there, it is 220, and then we have plus, and then this friction force is in the other direction, so it will be a negative. Then from there we know that the mass we have been given, which is 55, so 55 A is simply equal to 220 minus 189. So from there 55 A is simply equal to 220 minus 189. So you just get your calculator and say 220 minus 189, which is giving you 31. So you are going to have 31. Then you divide throughout by 55, so acceleration will simply be equal to 31 divided by 55, which is just simply 0.563 meters per second. So this was the acceleration which is supposed to be gotten. So where is this 7 marks going? So the 7 marks still is also benefiting the, it also catering for the what, for the free body diagram which I have drawn there. But if you have already
Squared.
if you have already drawn, if you have already drawn the first one, this one here, you don't have to worry much about drawing again. Okay, so that's how the 7 mark was coming about. The next one is my last part, the last part, which is B. C, you are going to research because that's more of theory and someone can easily click and check in their books. So I'll go for B, the next one. So for B, it's still depending on the, for B, it's still depending on the free body diagram. Okay, for B, it's simply also depending on the free body diagram there. So for this one, the only thing needed is just for you to understand what it simply mean when you have a mu and how to find the final answer. So for you to find the final answer, when you have been given the coefficients of static friction, you're just going to say tan theta is simply equal to mu k. Okay, tan theta is simply equal to that particular guy. And then what you're going to say is tan theta is simply equal to 0.04. So theta will simply be equal to the tan inverse of 0.04, like that. So theta in this particular case will simply be equal to, you just click on your calculator, of which you're going to say the tan inverse of 0.04, so which is just simply giving us a small angle which is 2.29 degrees. 2.29 degrees. Now find the smallest angle from the horizontal at which the box begin to slide. So this is the small angle which we are going to consider when you have been given the theta. So for this 7 mark, it was more like a free mark, but the reason why it was having 7 mark is that the reason why it was having this 7 mark is because of that formula. A lot of people don't know how to use that particular formula, and most of the books, they don't have this formula. Yeah, so most of the books don't have this formula. If you check most of these physics books, they don't have that formula. So what we are just simply talking about is, let's say we have that particular force, which is the Fn, and then let's say we have a friction force which is going this side. Okay, the friction force which is going this side, and this can be treated as Ff. So a friction force can go this side or it can go that side. Okay, so from there, if you observe very well, the small angle we considered, it is just the angle which is somewhere there, like that. So from here, if this is the force F, okay, if this is the force F, so one thing that you need to understand is the normal force is acting as your y coordinate. Your normal force is acting as your y coordinate, and the friction force is acting as your x coordinate. And these guys, they do make up the frictional coefficient of friction, but I am not supposed to go much in detail on that. The only thing I can tell you is you have to make sure that you know that particular formula for you to reach at that point. So this was the smallest angle of interest. So for now, if you guys have questions, you are free to ask now, but for those who might have questions after this class, you are also free to WhatsApp me on any of these numbers.